building on the sustainability topic we've talked about, we heard panelists talk about, the next keynote will provide us insights on how the biggest utility company in France, EDF, is exploring the usage of quantum computing. And to talk about that, I'd like to invite on stage the head of quantum computation at EDF, Joseph Mikael.
Thanks a lot. Thanks a lot for the invitation on behalf of EDF. Thanks a lot to Pasqal team for the journey that we've been through the last 5 years. So it's a pleasure to work with you, and hopefully we'll continue working with you. So I've been asked to describe what makes a use case. So we talk about use case since the beginning of this event. So I want to take the opportunity here to describe what it is actually a use case. And I describe the quantum journey of a use case from the very beginning to from the very first POC to the hopefully the highest possible TRL of the use case. Everything starts with the identification of the use cases across the company. So at EDF, it took us at least 1.5 years to figure out what we could do with this kind of hardware, with this kind of technology. And once you've done that, you have to figure out what you can do with it, so how to test it. So you try to test the first algorithms that are available, and you figure out that it doesn't work for your use case. So there are two kinds of companies, companies which will stop here, and a company like EDF, which will try harder and assume a plateau of commitment into the development of the use cases. We are now at a stage where we can test the algorithm. We can test the use cases on a real machine, and hopefully in the next couple of years we'll be able to use them at scale on our operational framework. So what makes a use case? First, you have to figure out whether, for a specific case, you have used the best-in-class algorithm on the classical side. I don't believe to the quantum jump between an Excel spreadsheet and a quantum computer. So you have to be sure that you've used the HPC stuff, the GPU stuff, the best possible algorithm in place. And I really like the numbers on the right here on mixed integer programming, which is used by almost every company. We benefit from a 800 billion factor in terms of speed up if I accumulate both the hardware and the algorithm improvements. So you have to be sure that you reach the classical limitations. You have also to be sure that there's a return on investment on the use case. So it may be quite evident to say that, but for some company, but I don't know a lot of them, there are no impact for any use cases. And for other ones, there might be an existential impact for at least one use case. And sadly enough, to me, I see a lot of companies in this situation who don't put any sense in quantum computing. At EDF, we have moderate to high impact in at least 7 or 8 use cases. So that's why we put an effort on it. You have to be aware to the execution time. If your needs is to run a quantum algorithm online, an optimizer online, maybe quantum computing is not the right client for now. I'm really thankful to Pasqal because they provided us with a roadmap on the frequency of their machines. And I guess you are the only one doing that in the place. So it's important to figure out what will be your usage of the hardware in terms of time needed to do the computation. Finally, it's all about scaling. it's about scaling in terms of hardware, in terms of qubits, in terms of how these people, these guys, are manufacturing their machines, but it's also a matter of scaling on the algorithm side. Having good performances on a machine learning algorithm on a small data set doesn't mean that you will be able to feed a machine learning algorithm with billions of data. That's why at EDF we prefer on the machine learning side to go deeper into the frugal algorithm, so the algorithm that doesn't need a huge amount of data, because we know that it might be difficult to train on a quantum computer. Really finally here, it's a matter of hardware. So stop being agnostic, it won't work at all. So Pasqal has a very nice machine, very nice properties of say, the ability that these guys have to place atoms to do their annealing is really interesting to us. And taking an algorithm from an IBM's hardware to a Pasqal one makes no sense. So you have to adapt yourself to the target hardware. Once you've done that, once you've identified your use cases, you have to give it a try. So you give it a try. Of course, it won't work, so you'll be disappointed. But you have to take a deeper dive. Take a deeper dive means that you have to do the math. You have to figure out how you will encode your problem, how you use the ability of the machines. You have to put in place some collaborations with startups like Pasqal, for example, academics and other big industries like us. It's a long journey, and when you start doing quantum, you're kind of enthusiastic like a teenager, so you go and search for the quantum supremacy, but maybe when you'll gain some maturity, you'll figure out that somewhere in the road, there are other fruits, like the energetical advantage, which might not be the quantum supremacy, but I mean, we'll take it. We'll take it. Energy consumption just for solving partial differential equation is €2 million per year, just to give a number. Of course, the quality of solution, the problem size increase, the acceleration, is other fruits. Now we are here. We are at this step where we can do the test. So we did a couple of tests on emulators, thanks to Atos on their work. Hopefully, now we'll try to demonstrate some kind of advantage with you guys at Pasqal. So we started doing that on smart charging problem. We'll continue doing that on other use cases, so stay tuned. And thanks to the roadmap, thanks to the tests that we've been doing, we managed to forecast the date. And to us, as a big company, it's the most important thing to do. I have to tell my bosses, my sponsor, when we'll be able to use this kind of computer at scale. It's a fast-moving area. The last year showed us that just on the error correction stuff, we saw a big improvement in terms of scaling. No definitive opinion can be set today, and I change my mind every 2 or 3 months. So when I see someone who set up his mind in 2018, it makes no sense. So you have to adapt yourself. This is a fast-growing area, and I'm pretty sure the only thing that I'm sure of is that Pasqal will be here in 5 years. At the end of the day, at the end of the journey, it's good to do some tests. It's good to assess how you will integrate, how the algorithm scale and so on and so forth. But you have to understand how you will integrate quantum computer in your data center. You have to imagine right now what will be the integration workflow of the quantum computer. In terms of integration, will you have access to cloud provider, and so on and so forth. But these are questions that have to be asked today. And thank you. I'm on time.